Greetings, class. Welcome to week one, starting out on data communications and computer networks. Today, we're going to go over week one. With some of the things, we're going to do somewhat of a deep dive, others not. What we're going to be concentrating on today is basically to get down to definitions. So what I'm going to be showing you is going to have a little more detail than just a definition, but it's going to set the foundation of what we're going to be doing, looking at our in-class work, looking at our project, looking at our Cisco implementations. So this is basically setting that foundation. Again, I want to go over here now for you to kind of jot down any questions you might have. And as I relayed to you before, there will be a quiz. Okay, on this is so expectation is that you will look at this video, and then from this video, you'll be able to answer some high level questions. Okay, so look everything at a high level at this point. I would not expect you to have definition for all, but this is basically gives me a participation kind of idea of whether you looked at the video and whether there's some specific things that you don't understand. Okay, so in looking at what we're going to be covering today, the key things here, we're going to be basically giving an introduction to definitions for data communication, looking at definitions for network types, looking for definitions associated with network topologies, looking for definitions of transmission media items, the OSI reference. And can we talk about what that means and what the implications are? Data encapsulation. Yeah, what does that mean? And what are the key fields or key values in there that you need to make sure that you know? TCP/IP model and how it compares to the OSI model. The journey of a packet from the time it releases itself from your computer based on data you're sending to the point that it gets to its endpoint. Okay, and basically where it needs to go. So we're going to look at that high level journey, look at the definition of key terms associated with that. And then we have our common networks devices on a high level, looking at those. What are they? And then in class, we'll probably get into the real world network examples, the key concepts review, and then what's next down the road, which basically were covered in the information that you looked at in the intro. Okay, so in the intro. So with that being said, what we're going to do is okay, so looking at section 1, the introduction to data communications. So what are the key pieces? The key pieces of any kind of communication, I kind of relayed this out in the intro, is that you have a point A, point B, and you're trying to get information from point A to point B. That is done here via the sender and the receiver and the message. So the sender, the device that originates the transmission, message, the information being transmitted, what are you sending and expecting for your receiver to receive, and the device that accepts the transmitted data. Those are the basic terms for data communication. Point A, point B, how do I get from point A to point B? So looking at some other key definitions, the data, which is basically looking at the bits of 1, 0, not really any formatted type data. Raw facts or information that can be processed into meaningful information. Information, data that has been organized or interpreted to provide meaning. The electronic exchange of data between two or more devices, that's data communications. Network, a collection of interconnected devices that share information and resources. Node, any device connected to the network, that's a node, such as a computer, a printer, a router, and here we have a host, a network device that is capable of sending and receiving information. So this here, the sender is a network device, the receiver is a network device. Both of them could be hosts, depending on which direction we're basically passing information. Again, we're going to be doing more of a deep dive the rest when we meet in class. This is the high level definitions of the key things that are associated with introduction to data communications. Okay. Yep. And I went the wrong way, and I apologize for that. Okay, so network types. Okay, most of these are familiar with everyone. So this is basically, there may be a few here that you really haven't been touched by, but this is kind of the overview of the network types that are basically being utilized today. PAN is a personal access network. LAN is a local access network. WLAN is a wireless local area network. MAN is a metropolitan area network. WAN is a wide area network. Internet is the global network. It can get from anywhere to anybody. Internet, private internal network, and extranet. An extension of an internet that provides limited access to external users, such as partners or customers. They're putting that extra layer of network for security purposes is what the purpose of the extranet. So again, not to look at the specifics of each because we're going to be delving on those, but as far as when you look at the particular acronyms, what they mean, here you can refer back to what they mean and what is their scope. We'll be looking at this in detail, okay, during our face-to-face. Those who are online, you will get the lecture that I give in class. Okay, so don't feel slighted, okay, because you'll be getting the same information that they are basically getting. Okay, so those are the definitions for network types. Okay, and we'll be discussing those in more detail. Okay, network topologies. Okay, this is the different ways we can put a network together. Okay, here we got the bus topology, the star, the ring, the mesh, the tree, and the hybrid. Okay, we'll be talking about each one of those. Okay, we'll be delving more into, we have the advantages and disadvantages here. What I'm concerned here, again, a definition, when you hear the word bus, you recognize what that is. When you hear the word star, you recognize what that is. When somebody says this is a tree topology we're using, you understand what that is. Okay, so again, this is going back to when we did the intro, we said we don't want to just define things. Okay, we want to know how it's actually used. What is it doing? Okay, so even though you may, look at these to say, okay, yeah, I know what a ring is. Know the effects. When we talk about this in class, we're going to talk about the advantages and disadvantages. We're going to talk about, hey, would it be better for us to use a star topology, or would it be better for us to use a tree topology based on what we're trying to do? Okay, so that's kind of the introduction to the network topology terms. Transmission media, this is how do I physically transmit data from point A to point B, from the sender to the receiver. What are the methods that I can use as a hard piece of media? What are my options on sending that information? Here, we're going to delve in more, but we're going to talk about the twisted pair. Definition-wise, it's made up of pairs of copper wires twisted together to reduce electromagnetic interference. Coax cable, okay, consists of a single central copper conductor surrounded by insulation, a shield, and then an outer layer. Okay. We'll talk about this. When should we use the coaxial cable versus when should we use the twisted? We'll be talking about that. When should we use a fiber optic network? What are the advantages? When is it not wise to use a fiber optic? We'll be diving into that. Okay. Other thing is radio waves, microwaves, infrared. Okay, these are all other mediums, transmission mediums that we can use. So we'll delve in that and look at the quick comparison in class as far as what the advantages and disadvantages are and where we might use one transmission media versus another. Okay, the OSI reference. OSI stands for Open System Interconnection Model, and it's a conceptual framework that standardizes the functions of a communication system into 7 layers. Each layer performs specific tasks and provides services to the layer above it. So in this particular case, we have an application layer. Okay, under that we have a presentation layer that gives basically gives support conceptually to the application layer. The session layer supports the presentation, which supports application. Transport, again, going up the chain, 4 to 5 to 6 to 7. The network layer, okay, moving it up, supports network transmission. Data link, 2. Physical layer is the last layer. That's the physically, how do we transmit the data so it can get from point A to point B. So each one of these layers supports the layer above it. Okay, so if you look at these, here are the main functions as far as the definition of what each does. I expect you to know those. Okay, what does the application layer provide? What does the presentation layer provide? Okay, these are kind of questions I probably definitely put on the quiz. Okay, so look at that, understand what their layers are and what they might do. Okay, here, example data encapsulation sending. Okay, we're going to talk about that next, but this is kind of rolling you into the fact that how we're moving up these layers, how they're affected about what happens to the encapsulation process. Okay, here, how do layers communicate? Okay, we'll begin delving into that. But the key thing here is this is a general structure, a general structure of layers on how we move data down the chain in order to get from the sender of the data to the receiver of the data. What are the various paths that our data have to take in order for that to happen? Okay. Data encapsulation. Okay, data encapsulation is the process of adding control information, headers and trailers as data moves down the OSI layer. Later on, you see also as it moves down the TCP/IP layer. Okay, but here's the definition of encapsulation: the process of adding headers and sometimes trailers to the data it moves that as data is moved down the OSI layer. So we basically think of this encapsulation as I'm taking data and I'm putting it in an envelope. Okay, I'm taking that envelope. When I get to the next layer, I'm putting it in another envelope. Okay, I'm taking the fourth one, and once I get there, I put it in another envelope. Okay, so encapsulation here is the process of adding headers and sometimes trailers as data moves down the OSI layer from 7 to 1. Each one of these encapsulation, think of it as an envelope that I'm putting the previous piece of information into at this particular layer. Okay, so encapsulation, decapsulation is the reverse process. We'll be delving into that in next class. What's in the header? Control information added to the front of the data of each layer contains addressing, sequencing, and other control information. And then there may or may not be a trailer. Okay, control information added to the end of the data as certain layers, for example, a data link layer for error detection. If I don't get that trailer, I know that I have gotten an error. Okay, so that trailer is basically letting me take that information and basically putting information in it so I can ensure that my data that I sent from the sender was received by the receiver. Okay, data encapsulation. We'll discuss this other information as far as what are the other things that we need to consider from the point of view of encapsulation and decapsulation. Okay, here we're talking about HTTP, how we move down the layers, how do they basically align with internet protocol. Okay, we'll be talking about that. Okay, and then talking about layers in the PDU. Okay, PDU names. Okay. We'll be discussing that. I do want to highlight here, if I don't give you a definition of something, okay, in this particular case, I didn't tell you about a PDU, which is a protocol data unit, okay. As I said, my expectation from you is that we're going to take that information, things that you may not understand, may not know the definition, but you want a better understanding, look it up, okay? Look it up. There are several times when you're going to have information that you may not know or you need clarity on, that you're going to need to take that next step and do some research as far as what is it meaning and how am I using it, okay? Hey, TCP/IP is a protocol similar to OSI, but it is the model foundation of the internet. Everything in the internet basically uses TCP/IP protocol. It has 4 layers: the application layer, transport layer, internet layer, and the network access layer. Here, sorry about that. It's called fat fingers. Okay, so with excuse me, wrong one. Okay, OSI, data encapsulation. Okay, so TCP/IP. Okay, so there are 4 layers, and here we got the purpose of each layer and what happens, and we've got examples of the protocol. We'll look at that, okay, and compare it to the PDU, and where we look at the things that are at a packet level. Okay, but we'll walk through and have a very good understanding of how the TCP/IP protocol works. And basically, you're going to reinforce this with information you're going to get from doing the homework assignment and also the quizzes. Okay, so that's TCP/IP, OSA, TCP/IP. These are the things that a lot of information, but this is going to lay that foundation for you. Okay. So here, as far as network devices, okay, some of these you've already heard, others you may not have, but this is when we talk about, we're running things through the router. Okay, what it does, connects different networks together. A switch connects devices within the same network, transfers information from one device to another device. It uses that in the LAN. A hub connects multiple devices in a LAN. It is basically, a hub is just that. It is the central point that all information goes into before it's sent out. Okay, comes through the hub. Wireless access point. Okay, what that is, it provides for wireless connectivity for devices. Depending on how you put things together, you may be restricted by the length of whether the length of effectiveness. Okay, so some things that you use, it's only good for 100 meters. Some things you use, it's good for a mile. Okay, so there are different things that we can use, and basically access points are what are some devices that we can which basically gives you a kick. Okay, I made it through the first 100 yards. Okay, I'm gonna put an access point to help me boost me to get to the next 100 yards. Okay, so that's what an access point does. It's a booster as to getting information down the road. Okay, so wireless access, the modem, the firewall. Okay, some of these terms you are pretty familiar with, I'm sure. The network interface card, okay, allows the device to connect to the network. Yeah, must have an interface card. A repeater regenerates and amplifies signals. This is an example similar to what we talked about for the access point. It's a repeater to boost that signal down the line. Okay, a bridge, okay, connects 2 network segments. Okay, so I can have 2 things on 2 different networks, and I need to have that information transmitted. What I can do is I can take that information and run it through a bridge. That bridge will connect the 2 networks. And then, of course, we have the server, provides services and resources to clients on the network. Okay, that is kind of common. Your laptop can be a server, or you might have a server that is purpose for everything, all laptops in your company going to a given server. Okay, so here's kind of an outline of how things work together. Again, we'll be doing a deep dive on this information on Thursday. Okay, so expectation is, and I'll send out an email that once I open this up, that you guys start looking at it immediately. immediately. As I said, don't wait. Okay, and you'll see if you haven't looked at the intro yet, be sure you look at the intro. Okay, some good stuff in there that are basically I'm expecting from you. Okay, so this we're going to be talking about in class, kind of more detail, the topology. So I'm going to stop here. So basically moving back, key thing that then we'll get into more detail. But here, as far as the topologies, that's here, network types. Key thing here is this is what I want you to kind of look over. Okay. By the way, the quiz is going to be closed note, closed book. Okay. So my expectation is, and they will come from this high level. Okay, so from this high level list of what's happening in data communication networks, both from an overview of content. If I asked you, what is a topology? Okay, I might say that, okay, here's some terms, match them to the right thing that is most closely associated with. Okay, so again, look at that. Sorry about that. Look at that, read it. Okay, look at that, read it, understand it from a high level, and then we'll do the deep dive for this particular week on Thursday. So everyone have a good one. Again, go after it, jump into it. Don't wait. I'm going to be very disappointed if come Thursday I ask you, did you look at the intro? And did you look at week 1? And the answer is no. Okay. I will send you an email to make sure that you're basically looking at this information. Don't let it slip. There's a lot of information here. And the fact that you don't go ahead and jump into it is just going to hurt you down the line. I don't want that to happen. So everybody, have a good one. And I will see you on Thursday to talk about data communications and computer networks, week 1. Have a good one.